So next we have some proof, that is Eijk and del of Ik, that is equals to 0. So we have to check this condition that this result is equals to 0. So I am now solving this. As we know that Eijk and del jk, so that means the j is repeating here and also the k is repeating here. So I write Eijk and del of jk, that is equals to Ei and that is j and j. If I am taking this fixed, so I am going to change these values. So I can write it like this. Now further expanding it, that Ei11 plus Ei22 plus Ei33. And we discussed earlier the definition of Lewis-Witter symbol, that if we have these two, you can say numbers, these two indices I and j, if they are equal, so that means this result is 0. So that is equals to 0 plus 0 plus 0, and that result is equals to 0. So this is the proof here that Eijk del of jk is equals to 0. Now the second proof here is we have to check that Eijk and Eijk, that is equals to 6. We have to prove this. So for this we know that we discuss a result here, that Eijk and ELMK, that is equals to del IL and del JM minus del IM and del JL. So this is the proof we discussed in our previous video. So I am using this. Now setting here or letting L, that is equals to I, and M, that is equals to J in the, you can say, in the above equation. This is called the equation 1. So we have Eijk and E, in place of L I am putting I, in place of M I am putting J and K as it is, that is equals to del I del J minus del I J and del J I, like this. And this result is basically, you can say that the value of this is separately 3 and the value of this is 3, minus I can write it in the form combinedly, that if these two indices are same, so I can write it like this, and this is also equals to 3, so 9 minus 3 is 6. So that means Eijk and Eijk, that is equals to 6. So this is the simple proof of this thing here. Now the third proof here is we have to check that Eijk ELJK, that is equals to 2 del IL. So for this I am taking this equation here, that we know that, now write again here the equation 1. Now here is I am putting M equals to J in equation first. So we have Eijk and EL, in place of M I am putting J K, that is equals to del IL del J minus del IJ and del JL. We have this condition here. So this result is equals to, this is equals to 3. So 3 del IL minus, we have combinedly I can write it as del IL. This is also IL, this is also IL. So subtracting I have 2 del IL. So this is the thing here. What we have to prove is Eijk and Eljk is equals to 2 del IL. Now the further is we have another proof. The fourth one is Eijk ELMK del of JM, that is equals to 2 del IL. This is also this, but here del of JM is multiplying with this term. So for this I am now writing this term, that EIJK and ELMK del JM, that is equals to del IL del JM minus del IM and del JL into this term remains same, del JM, using the relation between the Kronecker delta and Lewis-Witt. So I am writing the value of this in the term of the Kronecker delta like this. So this result here is equals to del IL del JM into del JM minus del IM del JN and del JM. So that is equals to del IL and del Mn. I can write it in the form of the JJ also. So I am writing del mm minus del Im and del we have here is Lm. Sorry, this is here, so we can write it like this. Now in the next step, this is equals to 3, so 3 del IL minus, I can write it as del IL, and this result is also 2 del IL. So this is, so I prove it here that Eijk and ELMK del JM, that is equals to this result. Now the fifth one here is EIKS EMPS, that is equals to ESIK ESMP, that is equals to EKSI EPSM. So I am going to prove this result, that is equals to same. So if I see this result, that is basically a cyclic permutation of the suffix in the EJK does not change its value. That is, we have here is what is the question here? IJS, sorry, here is J. IJS EMPS, like if I can write it like this, this is I, this is J, and this is S. So this is the, and the other one is we have M, if I am taking this M and this P. So E, you can say I, J and S, and E, that is M, this is P, MP and S, this is cyclic, and this result is also equals to S, I, you can say that this is, sorry, here is K here, this is the K here. So that is S, I, K, this is again cyclic, and then further is SMP, so this is again cyclic. Now further is KSI, that is KSI, and EPSM. So all these are cyclic, so this does not change its value. So this is the equal result here. So, and this is the explanation of this, you can say, of this proof, that a cyclic, you can say that a cyclic permutation of suffix in EIJK does not change its value. So this is the reasoning here. Now the next is the sixth one is we have to check that 1 over 2 EIJK EIJL and AL is basically equals to AK. We have to prove this result. So we know that I'm using a result here. We discussed earlier that 1 over 2 we have EIJK and EIJL AL. Now here I am taking this result that this term we discussed earlier is equals to 2 del IL. So I am writing here is 1 over 2 using that result. So this result is equals to 2 del KL because I are same, K and L are changed here. So 2 del KL into AL. 2 cancel out with 2, only we have del KL and AL, and we prove a theorem, a result like this, that this result is equals to AK. So this is the proof of this, you can say, of this result. So these are the 6 proofs about the Lebesgue symbol. These are similar or in somehow similar to the Kronecker delta, the proof of the Kronecker delta.